we have two other functions that we're going to look at and see how to find the inverse function. The process is very similar on both of them. We still want to switch our x and y. We still want to undo everything with the order of operations backwards. Okay? Our first kind of function is a rational function. Oh, this is not the one that we're doing. Our rational function, we're only going to do the kind where you just have a variable on the bottom instead of both the top and the bottom. Okay? So we've got this process here. Now let me show you what that looks like. So we're going to start by switching x and y. So x equals 2 over y minus 5 plus 6. Again, we want to undo everything outside whatever kind of function. So it's usually in parentheses or has an unsaid set of parentheses. So we had the roots, we had the powers, and we had our lines that we were looking at. So in this case, a rational is a fraction. So you want to get the fraction alone first. So you get that by itself. Okay? So to get the fraction by itself, I need to undo anything outside the fraction. Again, we're going to use the order of operations backwards. So I'm going to subtract 6 here. So we have x minus 6 equals 2 over y minus 5. Now here, this one gets a little bit tricky. The reason this one is tricky is because we want to undo our fraction. Okay, so the best way to think of it is that I want to undo the fraction. Now how we carry that out is a little different. What happens is that frequently people want to divide by 2. But dividing by 2 doesn't get you anywhere. That still leaves your y in the denominator. What we're trying to do is get the y out of the denominator. So in order to get the y out of the denominator, we can multiply both sides by y minus 5. So we undo fraction by multiplying. Okay. So we multiply both sides by y minus 5. Now, it will be really tempting right here to distribute. Do not distribute. Just leave it as y minus 5 times x minus 6. And then that will equal 2 because our y minus 5's canceled or reduced to 1. Okay. So then we look here and we want to get our x by we're getting our y by itself, so we need to get rid of the x part. So this part here, if you had distributed, it would become nasty pretty quick because you would have a yx here, and then you would have a y and an x and a number, right? So this is why we're not distributing. So I want to get this part here alone. So if I want to get that part alone, I need to undo this multiplying. Well, to undo multiplying, we divide by x minus 6. So that gives us y minus 5 equals 2 over x minus 6. Okay? Now, there is a shortcut to this, and maybe you know this phrase. So we had done when we were solving for side lengths in trigonometry, you might have used the phrase, if x is up high, you multiply, and then if x is down low, you switch O. So if x is down low, you switch O. That's the part that we want to remember. We say switch O so that it rhymes with down low. Okay. So notice it was always in relation, so let me give you an example. So if we had the tangent of 34 equals 5 over x, okay, we solve this by if the x was down low, we switch O'd. So we switch O'd those two things, right? So then we got x equals 5 divided by tangent of 34. That same concept is used here. So notice from this purple part to right here, the x minus 6 went where the y minus 5 was, and the y minus 5 went where the x minus 6 was. So these two parts switched. So instead of timesing and then dividing, you can just remember if x is down low, or in this case our variable of y, you switch O. So we switch those two spots. Okay. So then I got rid of whatever kind of function it was. We got rid of the y in the denominator. So now I want to undo the order of operations backwards again. So here we're going to add 5. So then I get y equals 2 over x minus 6 plus 5, making sure the plus 5 is outside the fraction. You can end up getting a common denominator and simplify. I don't need you to do that. So since this is less work, we're just going to stop here. So then this becomes our equation. Okay. Now, if I give you an equation that looks like, let's do this one. Okay. This negative here, I'm going to put it up there. I would do the same thing over here. This negative I would put with the top. Okay. It just makes it slightly shorter. And so I like that better. Okay. So we're going to switch x and y. So we get x equals 2 plus negative 5 over y plus 6. Okay. Well, I want to get the fraction alone. Okay, so if we get the fraction alone, we want the orange part by itself. So that means I need to undo this 2. This 2 has a positive. Okay, make sure you're looking at the sign in front and notice that it's being added here. So some people will be tempted to divide by 2, but it's not being multiplied. This has a plus sign in front, so we want to undo adding it by subtracting it. So we're going to subtract 2 to both sides, so x minus 2 equals negative 5 over y plus 6. The y is down low, so we're going to switch O, and we switch O in relation to these two right here. So we get y plus 6 equals negative 5 over x minus 2. Okay? Which obviously is a much shorter route than timesing by the y plus 6 and then dividing by the x minus 2. Okay? So this is very helpful to remember. And then we are inside our function now, so we restart the order of operations backwards, so I need to get rid of any adding and subtracting. So I'm going to subtract 6 here, so we get y equals negative 5 over x minus 2 minus 6. Okay? And then I can rename this to f inverse of x. So the really tricky part with rationals is remembering how to undo the rational. So to undo the fraction, you have to multiply. So your shortcut to the multiplying and then dividing is with the, if x is down low, you switch O. Your switch O is always in relation to the thing on the left side and then the thing on the bottom, where I guess it could be reversed on the equal sign. But the thing that's by itself and then the thing that's in the denominator, those two things get switched. Okay? We also can find the inverse of trig functions. Now, we haven't gone over what our trig functions look like, but just so you can see, our sine function looks like this. Wow, that was horrible. Our cosine function, it's all the same top and bottoms, but I just didn't draw superbly. Drawing is not my strength in life. So this is the cosine graph. And then our tangent graph looks like this. Sort of. None of those are drawn superbly. But the idea is that if I do the horizontal line test on any one of these, they all miserably fail because it touches it way more than one time. So for finding the inverse function, we need a domain restriction. Now, because we haven't gotten into much with our functions, our sine, cosine, and tangent functions yet, you don't know how to restrict the domain. So it's just given to you. So these are the domain restriction. Okay. So it tells you what part of the graph we're looking at. So for a sine graph, I would be looking at this portion of the graph. For a cosine graph, I would look at this portion of the graph. And then for a tangent graph, I would look at this portion of the graph. Okay. Now, again, you don't know how to find those, but if you see in the yellow box in each one of these, it would pass the horizontal line test, pass the horizontal line test, and pass the horizontal line test. Okay. So those will just be given to you. So again, this just means, hey, we are looking at part of the graph. And we don't have to do anything with that. Okay, that's just to say, in order to get an inverse function, we only have to look at part of it. Okay, so we start the same way. We switch x and y, so we have x equals 4 sine y. Okay? Now, on this one, instead of getting the parentheses by itself, we want to get the trig function alone. So whatever the sine, cosine, or tangent is, that's what you want by itself. So I want to get this thing alone. So you can think of get whatever kind of function it is alone, or whatever with your parentheses. So I like to think of function because it works for all of these. It works for our rational graphs, you get the fraction alone. It works for sine, cosine, and tangent, you get the sine alone. It works for our roots, you get the root alone. It works for our powers, you get the quantity to the power alone. It works for our lines. Okay, so whatever kind of function it is, you get the function alone by itself first, doing the order of operations backwards. This one has no add, subtract outside of it. So I need to get rid of any multiply, divide. So I'm going to undo multiplying by 4 by dividing by 4. So I get x over 4 equals sine of y. So then I'm going to undo the sign with the inverse sign. So the inverse sign, these undo each other. The inverse sign of the sign, they undo each other. So we end up with the inverse sign of x over 4 equals y. Okay. And then I'm going to change this to f inverse of x. Okay. If we look at this one, the cosine one, okay. Now I could also, instead of using x as my variable, I could also use theta. So I could do this equation as f of theta equals cosine of 2 theta, right? Or I could just have it as y equals cosine of 2 theta. Okay? So just be aware that you can use theta as your x variable. So we're going to switch x and y. So we get x equals cosine of 2y. If you had done it with theta, you would do theta equals cosine of 2y. And then here you'd still solve for y, but your variable would be theta. Okay, similar process. So there's nothing outside the cosine. I have nothing being added or subtracted or being multiplied, divided. This thing here is inside the cosine. So to tell if something's inside the cosine, your parentheses will start after the end of the word, the trig word, and end after the variable, or where it tells you it ends. So those are your two options. So since there's no variables, it starts after the cosine and ends after the variable. Okay, so I can tell that this part is inside. So there's nothing added or subtracted. So then I undo the cosine. Well, we undo the cosine with the inverse cosine. So the inverse cosine we write as cosine negative 1. And then the inverse cosine of the cosine, these undo each other. So we get the inverse cosine of x equals 2y. Okay. Well, now we're inside the function, so we restart our order of operations. There's nothing to undo, add, subtract. We do have a multiply, so I want to get rid of multiplying by 2. So we're going to divide by 2. So I can have the inverse cosine of x all over 2. Now the divide by 2 is for the whole cosine. Now you do have the option to write this as 1/2 inverse cosine of x, right? That's still a thing that's possible because our 1/2 is, you take the said 1 from here and divide by 2, so it's 1/2 times by the inverse cosine. Both of those are acceptable answers. We started with an f of x, so this is f inverse of x. Let's look at this one. Okay. Again, oh, I missed highlighting this part. This part right here is saying we're only looking at part of the graph. So I don't need to do anything with that. It's just saying look from this value to this value. Okay. So I'm going to switch my x and y. So we get x equals sine of y over 3 minus 6. I know this minus 6 is on the outside of the sine or cosine because my parentheses ended here. If I wanted it on the inside, it would have to look like this. Okay? And then we would go about this problem differently than this problem because this is inside the sine, this is outside the sine. So since this one's outside, we undo that first. So I'm going to add 6. We have x plus 6 equals sine of y over 3. There's nothing being multiplied in front of the sign. There is a divide, but that's inside the sign, so I'm not worrying about that yet. I first have to undo the sign. So we undo the sign with the inverse sign. The inverse sign is its own function, so it goes on the left side. This will look like it's multiplying. It's not. It's its own function. So the inverse sign of the sign, those undo each other. So we're left with the inverse sign of x plus 6 equals y over 3. You do have to have parentheses here. Parentheses are optional here and optional here, but since we're adding and subtracting, in order to show that it's inside, I have to use parentheses. We're inside the function or inside our parentheses, so we need to restart the order of operations backwards. So I need to get rid of any add subtracting. There's nothing here, so that's adding and subtracting. So now I move to multiply dividing. Well, this is being divided by 3, so I need to times by 3. So I get 3 inverse sine of x plus 6 equals y, and then I can rename this to f inverse of x. Now, just so you can see over here, I'm going to show you how to do this one. There's nothing outside the sign, so I would undo the sign here. And then the inverse sign of the sign, those undo each other, so we get y over 3 minus 6 equals the inverse sine of x. Then we're inside the function, so now I undo, add, subtract. So this I need to get rid of next. So I'm going to add 6. So the inverse sine of x plus 6. You don't have to have the parentheses around the x right now, but you can. Then I need to get rid of dividing by 3. So I multiply by 3 on both sides. When I multiply 3, it needs to go to the sign and to the 6. So it's 3 inverse sine of x plus 18 equals y, and then I can rename that to f inverse of x. Now, if any equation I ever give you is just y equals instead of f of x equals, you do not need to write the f inverse of x at the end because it wasn't named f of x. Okay, so if I just have y equals, then you can just show your inverse as y equals as well. Okay. If I start with f of x or g of x or h of x, then to show that it's the inverse, you would do f inverse of x, g inverse of x, h inverse of x. And we write those with the -1 power. Okay? So notice these are very different things. This has the x plus 6 inside the sign, and then we times by 3. This you do the inverse sign times by 3, and then you add 18. Okay? So it makes a difference where your parentheses end. So if there's no set of parentheses, they stop after the variable. If there are parentheses, they will just be there. Okay? So those are how you find your inverse functions for rationals and trigonometry.